Have you ever wondered how routers communicate in a network? Today, we dive deep into the world of ISIS, a routing protocol that orchestrates this communication. Imagine a bustling city with its intricacies and interconnectedness. Just as traffic signals and road maps guide vehicles to their destinations, ISIS helps routers navigate the network. Much like a city's blueprint, ISIS provides each router with a comprehensive map of the network. This includes all connected links and their metrics, allowing for the efficient flow of data. Now consider a sprawling metropolis. It's divided into districts for easier management, right? ISIS applies the same concept to networks. It segments the network into manageable areas and assigns routers different levels based on their function. Level 1 routers work within their assigned areas. Level 1, 2 routers bridge these areas, and Level 2 routers form the core backbone of the network. Our bustling city wouldn't function smoothly without real-time traffic updates. Similarly, ISIS routers share link state packets, providing detailed information about their connected links. This constant exchange of information ensures optimal network performance. Now that we have a basic understanding of ISIS, let's delve into the steps to configure it. Moving on to the next step, let's talk about ISIS authentication. Think of it as a city's security system, where only those with authorized access can enter the secure areas. In the same way, ISIS authentication verifies the identity of other routers in the network. It employs mechanisms like MD5, similar to how a city's security system uses various tools to ensure safety. This step is crucial in protecting your network from unauthorized access and potential threats. In essence, ISIS authentication ensures that only legitimate routers can communicate within the network, making it a critical component in the configuration process. Now that we've set up our authentication, let's talk about ISIS metrics. Think of metrics as a city's traffic management system, considering different routes based on traffic conditions. Metrics in ISIS determine the cost of a path to a destination network. Several factors can define these metrics, including bandwidth, delay, and reliability. The importance of metrics cannot be overstated. They help routers choose the most efficient route, distributing the traffic load evenly across the network. In essence, ISIS metrics assess the cost of each path, helping routers to select the most efficient route, just like how a city's traffic system directs vehicles to take the most efficient route to their destinations. In the previous scenes, we discussed how ISIS metrics work like a city's traffic management system. Now let's take that analogy further. Imagine if that city's transportation system had to integrate with other modes of transportation, say, a neighboring city's rail network or a national airline's flight paths. That's what is redistribution is all about. Is redistribution is the process of exchanging routing information between ISIS and other routing protocols. It's like a translator or a bridge, allowing routers to share routing information across different networks, much like how different transportation systems need to coordinate to ensure passengers can travel smoothly from one system to another. So, the importance of ISIS redistribution in ensuring seamless connectivity across different network segments cannot be overstated. In essence, ISIS redistribution allows routers to exchange routes with other routing protocols, ensuring smooth and efficient network connectivity. Once you've configured ISIS and performed ISIS redistribution, it's crucial to verify that everything is set up correctly and functioning as expected. Think of it as a final checkup or inspection before opening a new transportation system to the public. To do this, you can use various commands like show IP protocols, show ISIS database, and show ISIS neighbors. These commands help you to inspect the ISIS routing process, the ISIS link state database, and the ISIS neighbors respectively, providing insights into the operation of your network. Remember, ensuring that your ISIS configuration is correct is not just about getting things up and running. It's about guaranteeing network stability, performance, and reliability, much like how a well-run transportation system ensures smooth and efficient travel for its passengers. So, never skip this step in your network management process. Network management is not always smooth sailing. Just like in a bustling city, unexpected issues can arise that require immediate attention and resolution. This is where troubleshooting comes into play in ISIS. If you encounter problems with ISIS, a variety of troubleshooting techniques can be at your disposal to identify and resolve the issue. For instance, commands like debug ISIS adjacency and debug ISIS packet can be invaluable tools in your troubleshooting toolkit. These commands help you to trace IS-IS adjacency changes and examine IS-IS packets respectively, providing valuable insights into the operation of your network. Remember, troubleshooting is not just about fixing issues. It's about maintaining network stability, performance, and reliability. So always be prepared to troubleshoot when managing your network, ensuring it runs as efficiently as a well-oiled machine. First, define the areas and levels in your IS-IS network. Think of it as drawing your city's districts and deciding on the hierarchy of administration. Next, configure the network entity titles, or NETs. These unique identifiers, much like postal codes, distinguish one router from another. The third step is to enable IS-IS on the right interfaces. This step ensures routers can exchange vital routing information with their neighbors. Finally, configure the priority of designated routers. This step is akin to appointing a mayor and a deputy mayor in a city. The designated router, like the mayor, broadcasts link state advertisements to all routers in the area. The backup steps in if the designated router fails. In summary, IS-IS is the unsung hero of network management. It keeps track of network topology, divides the network into manageable segments, and facilitates constant communication between routers. Configuring IS-IS involves defining areas and levels, configuring NETs, enabling IS-IS on appropriate interfaces, and setting the priority of designated routers. Remember, a well-configured IS-IS is like a well-planned city. It ensures smooth traffic, efficient communication, and overall network stability. And isn't that what we all want for our networks?